Which you're like, I don't want to be here. And then you're like, I don't.
Alright. Okay, real quick.
No one cares.
So can I, like, will the office let me, like, go take a nap though?
No.
I actually,
I had to suck it up or
think I have a fever.
So,
Suck it
hey,
up.
go to the office, you shouldn't be at school anyway.
I can go home?
Alright, no, you can go to the office and talk to them. Alright, so, hey, real quick. Properties on the board, you'll need this. I'm gonna talk about a problem today that you had yesterday that I didn't really feel comfortable with the answers I was getting. I understand where people were coming from, and here's the problem that I gave you yesterday. This was it.
Where we said there's no limit.
Yeah, I agree, like you plugged it in, it didn't show you anything. The problem is what you were supposed to do that no one attempted.
I didn't know how to attempt it.
Okay, I think it was something like this.
Do you not like our class? No, I wasn't. I don't know, you just seem mad at us.
Okay, alright, hey, real quick, I'd like you to have this problem written down. This is one we attempted yesterday. A lot of people looked at it and went, oh, it doesn't exist. And I understand where you're coming from because you plugged in 0. You plugged in 0 like this. You squared that part. You subtracted 27, and you got a 0 on the bottom. And you know the top turned out to be 27. All right, sorry, 9. It was 9 minus 27. All over 0. I think that was a 2, wasn't it? Or was it a 3?
I think it was 9.
It was a 3. It was a 3. That makes more sense.
3, go.
Okay. Hold on.
I'm so confused.
So then you do 27 minus 27.
Okay. Alright, this is the problem I gave you yesterday in that very last worksheet. This turned out to be was x plus 3 cubed minus 27. You evaluate by plugging in 0. That's how you can attempt to do limits if you wish. You can plug in the number and actually attempt to solve. The problem was, what this turned out to be, is it turned out to be 0 over 0. And most people said it doesn't exist. Like that doesn't work, you can't do that. I understand where you're coming from. The problem is, we have rules you can do that you can actually attempt to simplify. I tried to talk some people into like, you should try to like plug in numbers, like maybe set up or plug in some smaller numbers and see where it's going. Because obviously, 0, 0, yeah, like it's showing that there's a problem there. Here's what you're supposed to do. Number 1. And I don't think I saw anyone attempt this. Wait, I'll take that back. I think I've seen, there's 2 people that attempted to, that attempted to go further. Okay.
No one
Where's your work? Will you tell me?
No one got the perfect answer.
Where's your work? Who
I
was
got
it?
the perfect answer.
I can go through this.
I put
Me.
divide by 0 error.
No.
Okay. I don't know if I did.
Okay, hey, I do want this in your notes. You should have your notes out right now for this one. Okay, here's what you're supposed to do. This is what you're supposed to do. You're supposed to FOIL and factor these all out so you can actually see what's happening. I had a couple people that attempted to go further. They attempted. The top here, if I FOIL the first 2 together, that's x squared plus 6x plus 9.
6x plus 9.
Then I'm going to take that times x plus 3, because again, I FOIL the first 2 together. You get that over x. You still have to have the limit out front, so you can't forget that. Alright, and I'm not evaluating yet, because you still get 0 over 0, that type of thing.
That type of thing.
The next part, I would FOIL those next parentheses, or the first 2 parentheses again. This item times the next item. And this is where you'll start to see like what's going to happen here. If I actually FOIL these together, what you're going to get is you're going to get this. So limit as x approaches 0. On the bottom I have an x. And on the top, if I FOIL first, outer and last, in fact, let me get rid of this graph, this property sheet. We're going to use the property sheet here in a second. If I FOIL, that's x cubed, that's x squared times x, so that's x cubed. X squared times 3 is 3x squared. Next, taking a 6x times x is 6x squared. Taking the 6x times 3 is 18x. If I keep going here, taking 9 times x, that's 9x. Taking the 9 times 3, that's 27. And then I have a minus 27 in the back. And this is all over x. Okay. Questions, comments about how I foiled first, outer, inner, last, the big thing. It's actually distribution, that's what it's probably.
That is gobs, Mr. Ward.
Okay,
That is way too many gods.
it's big,
How many gods do you think that's equal to?
quite a few. Alright, so,
Holy
I'd
cow.
say only like
you.
19.
now, hey, if we simplify the top, what happens here is the 27s cancel,
Yeah, they do.
right? They go away. One's positive, one's negative, boom, gone.
Can we combine the like terms?
We can combine like terms, which is limit as x approaches 0. This is x cubed plus 9x squares plus 27x's all over x.
Mm.
And the last step here
You can cancel out X.
is divide everything by x.
Yeah.
Because you can still combine like terms, you can still do that log division, where you do this. Where you actually divide everything by x, because that's a rule that you're allowed to do in algebra. So this turns out to be x squared plus 9x plus 27. And the last step is, now that you don't have a problem, is you can plug in 0 and you can actually get to your final answer, 27.
No.
Okay, so this turns out to be 0 squared plus 9 times 0 plus 27, which is 27. That is actually where the limit is approaching.
So just divide by
Not, it's not, the limit itself, it appeared to be do not exist, because when you plug it in, we had an error there. But when you actually try to approach from the right and left side, the numbers would actually be 27. Some people attempted, I think I had two, I think, that actually attempted that.
Two. A couple two.
You need to think about that you can actually go further. Now, if I couldn't do that, let's say you couldn't divide, you couldn't FOIL that all out, or maybe it was just really big, you still need to take some time to see if you plugged in numbers around 0, like 0.2, 0.1, 0.001. And then I plug in negative numbers because I can approach from the right and left side and see if they're actually going towards the same number. So you can use a table. Questions at all about that one? Okay, moving on. Let's go to the next part here. I'm going to pull up that problem that I just had up on the board.
How do we know when we should keep going instead of just thinking it's do not?
You should always attempt to always try to attempt to FOIL, simplify, whatever you want to do. And then if it's still turning out to be 0 over 0, the next thing I would go to is look at the graph, graph it on Desmos, to see kind of where is it going. So if it's going to infinity, yeah, it doesn't exist. Or maybe it's approaching a number, but you just can't plug that one number in. So that's something. So there's little rules we check. For right now, we're sticking with 2. We look at the graph, or we just try to simplify as far as you can. All right. Now the next property sheet that I put on the board, I'm going to put that back up here in a second. This is the one that you had at the very, I think it was the very end of class. We talked, or actually it was the beginning of class. We talked about these properties. And what you had to do on that first problem on your property sheet, and I think almost everybody got this right, was they gave you 2 separate pictures of things happening. Okay, it was something like this. They gave you 2 different things. That was 1, this is a 1, that's a 2,
I don't like that. Don't do
and
that.
this is
Oh god.
a 2. Alright.
Why did you put the 1 and the 2 on different sides? Oh. Yeah, can you move the 2
Okay.
over, please and thank you?
Yeah,
And put a -1 there.
Good job.
The 2
I mean, you
and
put 1 and 2 on the opposite side of it.
1.
Everybody's OCD is freaking out. You have the
Mr.
1
Ward,
and 2 on
I
the
am-
y-axis on the opposite side,
Oh my goodness.
and then you don't have a -1.
And can you put a -2 on the bottom so they're all by 2?
Mr. Ward, go down to -3
Alright,
on one
now.
of them. Otherwise, my anti-OCD
Okay.
just gets mad.
Alright. Okay. So there's one graph. Let's call this f of x. Let's go to the next graph. This one over here. Same thing. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3.
Yeah.
8.
Unfortunate.
That's included.
Oh.
Wow. Piecewise.
Alright. So, and this will represent g of x. This graph. Alright. What the type of problem that they gave you, I think everyone actually did this really well. I just want to clarify one more time. If they ask you to figure out this, the limit as x approaches the number 1 from the left side. Okay. Actually, let's go 0 from the left. Let's just stay easy so it's easier to see. I don't want to have to try to interpret. Okay. So 0 from the left side, and I'm going to go f of x plus g of x.
I could do it.
1.5 plus 2. 3.5.
Okay, so we're starting to kind of see how this works. So on the first one, you have to figure out, because you can separate these into their own limits, and most people just do this in their head. They figure out the first one, the limit as you approach f of x towards 0, and then you add that to the limit on the other one where we approach 0 from the left. And when you find those separate numbers, you can add them together or subtract them or whatever you want to do. Divide, multiply, whatever it asks you to do.
I don't understand why it matters if you approach from the left or the right.
Because they might go to different numbers, like piecewise, might have like different numbers where it's heading towards. Like one might be going towards 1, one might be going towards infinity, and you're just looking at one particular instance. Okay, so as I'm going from 0 on the left, that's what this negative sign means. On the first graph, it looks like I'm approaching from the left side about 1.5-ish. We'll say it's that. Okay? So this is 1.5. And we're going to add that to, on the second graph, as we approach 0,
That could be
it's
like a
approaching
16.
maybe 2.
Because
We'll
we
say
don't
it's
have
a
a
2.
labeled graph.
And so the final answer here is that when I add these, I get 3.5.
Yes.
So the answer to this problem is.
So 3.5 is the idea of like what you're getting.
That's the limit.
Okay. Questions on any of these limit ideas, like how you're supposed to use them? We could have done this on the last problem. It's just that it's one of those things you don't have to do that. It's one of the times that, like, if your problem has a lot of individual formulas, it's kind of nice to break them up individually. The last problem was one continuous problem. It wasn't, piecewise like these are. So that's kind of the idea why we do these questions. So hopefully that answers your question, Ross.
Yeah, it does.
Okay, next. Last thing I want to cover here today.
Did you say gobs?
No.
Mr. Wood, have you ever used the word gobs just casually?
45.
No.
You liar.
I often find myself saying gobs.
No.
Okay.
The other day I got
Alright.
interviewed for my children's
Moving on.
hospital, and I
Anything
said,
to be
"Oh, you suck,
highlighted
Dad."
at this moment? I really like highlighting. I do
So is
too.
that mine?
Try to control our ADD for
It's called pause.
Why can't it be 88?
Pause children's hospital.
I don't think anyone's.
Oh, don't.
Who has ADD?
Sure, what do you mean?
Why?
Mr. Wood, aren't you warm
Do
today?
you have yours done?
You are dressed rather warm.
Yeah, but let's do mine.
You're wearing
Why are
You're wearing 3 layers.
He's actually got 6 layers on. 3 of them.
Actually, do what I want to
Okay. Alright. Real quick. Okay, I've covered everything except for this problem right here.
Yes.
Okay.
That problem is so easy.
Alright.
Is that a side graph?
It could be a sine or cosine.
Ooh.
It could be a tangent graph if you flipped it.
If you expand it out.
Wait,
Those are some rather random ones.
I don't like
Yeah, they don't meet up anywhere.
nose, would that be better?
So any of them should be like at a specific
Hey,
point. Mr. Wood, you don't really
Okay.
pick people off.
Alright.
Wait,
We're
where's-
looking at here.
Well, where is the
Just-
point F at? Like, on the graph, there's an F.
That's the function name.
Oh.
Alright. One of the problems you're going to have, because the whole point of us doing limits is to approximate what they call the average rate of change, the slope of a line. Average rate of change is when you just do your normal numbers like this in Algebra 1, where you subtract x's, you subtract y's, you put them in that formula, that's how you find slope. That's what we're doing. When we do that differential quotient, like that first example, where you have this style of problem, this is basically what that first problem was that I gave you, and you take a limit of this thing, and you approach 0, the difference between these two items, that this is an average slope, so if I pick 2 letters up here, 2 coordinates, and I actually subtract, that's an average rate of change between the 2 letters, right? It's just a straight line that connects A to B, let's say. But when I suddenly make it this is almost the exact same formula. The only difference is eventually I'll plug 0 in for h's. This is now an instantaneous rate of change, which is the slope directly at this point. It's not an average between two others. It's the exact slope at this exact moment. That's why we're actually finding limits. That's the whole purpose of like what we're going to. Okay? It's an instantaneous rate of change, which is an instantaneous slope at that moment. Because what this is actually doing is it's saying that, hey, you're going to pick dots that are insanely close together. Like insanely close, really, really close to
Like even closer than you
A.
just drew on the board.
Yeah, like way closer,
You
like
can't
within
be closer.
within 0.01, 0.001 of each other.
Like a pixel?
And so the idea is that when you zoom in, these will approximate a straight line. And one of the problems we're going to have you do is, other than finding limits, is to look at a graph like that and say, hey, what's the slope roughly right there?
When you
that's
flip the
negative.
graph upside
So-
down, I want to lose pixels.
Yes. So here's the idea.
What do you say?
Yes.
What'd you say?
If these are the slopes, let's say.
Why would you say?
So let's say the slopes off to the side are negative half, 0, -3. Let's go 4, and let's go negative 2/5. Let's say that these are the slopes. What I want is what coordinate, what point represents that slope at that exact moment. So you have what, 5 different slopes? They're going to give you these numbers.
Negative half is negative half.
So, and you have to go figure out which coordinate up there is roughly that slope. Two of them could be really close, so it kind of is a free-for-all, so in like that situation. So, what would A roughly be up here?
19.
It'd be -3.
-3 maybe? Okay, we'll say that's A. I would probably agree. You know, it's pretty steep. It's dropping a lot, running a little bit. So -3/1. So there's the slope for A. What would the negative half be?
That would be B.
B or maybe E, it's one of those two. The slope doesn't look like it's too steep right there. So maybe drop 1, run 2. Yeah, I can see B there.
Thank you.
What about 0 slope?
It doesn't have one, it's on 0.
C.
C. C. 0 slope is when your lines are directly horizontal.
I thought so.
Undefined slope is when it's up and down. We don't have any of that.
How far do we look at a picture?
What are you doing with your hands?
When we're finding the slope of the point, from how much?
I go as close as I can to the actual thing, put 2 dots, draw a line. That's what I look at.
Zoom in.
That's a
Zoom in. Okay, 4, positive 4, that's probably letter D. That's the only one that's going up to the right, so that's a positive slope, probably rise 4, run 1. That type of thing. Or, and then the last one, maybe letter E. It would be drop 2, run 5, drop 2, run 5, that type of thing. Alright, and again, these are approximate. Like the two that I would probably have problems with is probably, would be probably B and E. I could see that those could be interchanged. And like on my answer key, I'll probably have both sitting there just because it could be either or. The reason why we're doing all these limits is because that's what we're going to be finding these next couple weeks in here. We're going to be finding slope of curves, but at very specific moments. Well, we need to practice finding limits. Can you get better at it? Can you look at pictures, estimate what slope is roughly, and then we're going to try to fit the pieces together, and that's what we're going to try to do next week. Okay? So, today, homework. This homework I'm going to give you is due on Tuesday next week.
Do you want to
Due
know what
on
I did
Tuesday.
last night?
On the board over there, but I'm going to put it down here.
Hey, do you want to know what I did last night? I started
Sorry.
crying because calc is so hard.
Okay, good.
I swear
So,
to God I did.
You haven't even seen her yet. 1, 2, 11 through 14, 55 through 60,
It's almost
page 81,
You're gonna learn today.
numbers
number 14 through 17.
14 through 17,
25 through 28.
25 through 28. All right, there's your homework.
When I did that.
It's not too bad. You're not drawing anything for the ones that I assigned. You're basically finding a lot of limits. Read the directions. It says find a limit as you approximate, infinity. Some of the times you might just need to go look at a graph and kind of see where it's going. I would say like you can probably simplify the problems. You shouldn't need to go to a graph.
Can you give us a time frame on how long this should take?
I would say it shouldn't be more than an hour.
An hour? But
that's if you're consistently working.
About 20.
Now, the one thing I'm worried about is the problems we talked about yesterday. If you don't remember what we did yesterday, I showed you shortcuts for when, you know, functions are on top of each other, what the slope roughly goes to.
When does this due?
Tuesday.
Tuesday.
Why?
Why not?
That's the date that he sent the due.
Mr. Ward, what's the longest homework assignment you've ever assigned?
We sure one was after man.
I'm feeling it.
No, not you. Like, have you ever given someone a 4-hour homework assignment?
Yes, you have.
Wait, what is like a college hard math assignment? How long would that be?
My average assignments in college took me like 6 to 8 hours sometimes. I didn't even get sleep most nights. There was one.
What's your college GPA?
And you enjoyed that?
What's your college GPA?
He didn't care, he didn't apply himself.
3.1, 3.2, something like that.
And you,
But I was working hard to get that. It wasn't easy.
Mr. Ward.
Wow, that really makes me
And you
wanna
enjoy
go.
doing 6
I'm gonna
hours.
start crying.
You enjoy doing 6 hours?
No, there was many nights that it was
Were there-
painful.
Did you think
But
there were
I got better at it because then I figured out that if I worked with partners and I worked with groups, it was a lot faster than trying to do everything by myself. Because that's what they're trying to promote. They're trying to get you to that community
Why would
aspect
you
where
work on it
you
in
gotta work
class?
together to get the best.
Mr. Ward, did you cheat your way through your
No, I did not. I worked really hard for my grades.
Why would you ever break
I
that?
think that you just made it seem like you kind of job. Can you use the good old
Literally, I have no idea where my book
I
is.
didn't have Slayer back then. They didn't even have an Amazon back then, so I couldn't buy a teacher edition.
That's actually genius.
I did that later in life.
I did that
I
later.
can't get that many pencils.
You buy a teacher edition.